A function is a machine that when you put in it a certain number, it gives you a certain value. So we could say that a function that is f of x is equal to, for example, x plus 3. And if we want to know what is the value when x is equal to 1, then f of 1 is equal to substituting x with 1, then 1 plus 3 is equal to 4. We can express that as a point. X is equal to 1 and y is equal to 4, relating to each other. So if we want to find the derivative or the rate of change of a certain function, we know that this rate of change is simply the slope. So we need 2 points and find the slope. The slope as delta y by delta x. Then let's say I have a point x and its y is going to be f of x, and another point at which I'm adding a small interval in the x. So it's x plus delta x, and its y is going to be f of x plus delta x. Then the slope is going to be the delta y divided by the delta x as f of x plus delta x minus f of x divided by x plus delta x minus x. And we see that the negative x is going to cancel with the x. So it's f of x plus delta x minus f of x divided by delta x. Let's say we want to find the rate of change at a certain point, or the instantaneous rate of change, or we could say that the 2 points we're talking about are very close to each other as to the delta x is approaching 0. This is the definition of a limit as delta x is approaching 0. Then it's going to be equal to f of x plus delta x minus f of x over delta x. And this is the definition or the first principle definition of a differentiation or a derivative. Let's see it in action. Let's say we have a function that is equal to x squared, and we want to find the derivative using this first principle definition. So then, gonna say df by dx is equal to f of x plus delta x minus f of x divided by delta x. Then I'm gonna evaluate each part of this equation here. So let's start with f of x plus delta x. Our function here is x squared, so we're going to substitute x plus delta x and the x as x, so it's going to be x plus delta x all squared. And that is equal to x squared plus 2x delta x plus delta x all squared. Then the numerator becomes, gonna write it here little by little. The numerator becomes the f of x delta x is x squared plus 2x delta x plus delta x all squared minus f of x, so minus x squared divided by delta x. The negative x squared is going to cancel with the positive one, and we're gonna end up with this version here, as we can further simplify by canceling the delta x with the delta x here and the square here. So it's going to be 2x plus delta x. And as we're saying that the delta x is approaching zero, then we could say that the derivative is equal to 2x. As we all know from the simple differentiation rules. I also want to mention that a function must be continuous for it to have a derivative. Let's say if this is our x, this is our y, and I'm going to put actually the zero here and the zero here so we could see simpler uh, the negative and positive. Let's say here that is 1 and here that's a negative 1. We can see at x equal to 0, there is a jump in the function. As to if we are approaching the function from the right and from the left, it's not going to be the same value. The right side and left side values are not matching, they don't meet, then the limit does not exist, so we can't have a tangent at this point or a derivative at this point. Also, continuity may not be enough because we could have a continuous function that looks like this. It is continuous, but at x is equal to 0, also approaching the function from left and from right at this specific point gives us different values. So the limit don't exist. So we wouldn't be able to have a derivative.